Ramanujan for G is now available on the Google Play Store. Try it out for free.
Morning, guys. So today for the JE lecture one, we are going to start the new unit, which is the probability, right? So let us start. Probability. Okay. So first, moving to probability main concept, we will focus on the set theory. Okay. Set theory. So let me write the collection of well-defined things. What is set? Set is a collection of well-defined things. Okay. Now, what do you mean by well-defined things? Okay. So we can write well-defined means a law by which we are able to find whether a given thing is contained contained or not in a set. Okay. So here, if we go for example, let A be a set x2, x, an odd number less than 15. That means set A contains 1, 3, 5, 7, 9, 11, 13. Right? So this is the set. So again, we are repeating what is set. Set is a collection of well-defined things. Now, what do you mean by well-defined? Well-defined means it is a law by which we are able to find whether a given thing is contained or not in a given set. So here we are taking example a set which is giving a condition which is there is a terms x having an odd number less than 15. That means set A containing 1, 3, 5, 7, 9, 11, 13. All these are odd number less than 15. Correct? So copy this. These all things will required in probability concept. Okay. So we are covering here. Okay, so I hope you copied. So next thing we will look operations of the set. Okay, operations of set. So there are few basics operation. Let first is union of set. The union of set is represented by A union B or A plus B. This set contains those elements which are in A or in B or in A and B both. Okay, what does it means? Let it be a set A, let it be a set B. Now, set A containing some element, set B also containing some element. These are some common elements. So this is A union B. So we can write A union B is equals to X, X belongs to A or X belongs to B. Correct? So you can copy. Okay. Next is intersection of two sets. Now the intersection of two sets is represented by A intersection B or AB. It contains those all elements which are contained in both set A and set B, means both. So if we draw, means let it be set A. This is our set A, set B. It's containing both. That means, so about this area, this is A intersection B. So we can write A intersection B, x of x belongs to A and x of x belongs to B. Correct? Finished. Next is difference of two sets. A and B are two sets, then A minus B represent the set of those elements in which are in A or not in B. In the same manner, B minus A represents set of those elements which are in B, not in A. So we can represent, let it be set A, let it be set B, set A, set B. So this A minus B, this is B minus A. Or it can be written as A intersection B bar. That means only this one will not contain this. Okay. So we can write A minus B is A intersection B bar is equals to x of x belongs to A and x not belongs to B. Okay. So in this chapter, symbols plays very important role. You need to remember. Okay. This question will ask in this format only. They will not give the proper language. They will write in a form like this. Okay. Now some basic terms and concept for probability. Okay. First is an experiment. First is an experiment. So, what is an experiment? So, an action or operation resulting in two or more outcomes is called an experiment. We can write action or operation resulting in two or more outcomes. Example, tossing of a coin. So there are two possible outcome, head or tail. You can write tossing of coin, head and tail. Similarly, we can take one more, drawing a card from 52 cards. So so there are 52 possible outcomes, right? So this is an experiment. You can copy. Next is sample space. Okay. So the set of all possible outcomes of an experiment is called sample space. It is denoted by S. Means set of all possible outcomes. Okay. And an element of S is called sample point or sample element. Okay. So we are going to take example. Like in the experiment of tossing a coin, in the sample has two following conditions. Means if you go for S, you can write head or tail. Right now, when we throw a die, then any of the numbers 1, 2, 6, 5, 4, 3 will come up. So the sample space will be 1, 2, 3, 4, 5, and 6. Okay, so this is our sample space. Okay, next thing is event. So any subset of sample space is an event. Any subset of sample space. So like example, in if the experiment is done throwing a die which has the faces number 1 to 6, then as we know 1, 2, 3, 4, 5, and 6, right? So like A set which is 1, 3, 5, and B set 2, 4, 6, and the null set is this 5, and S itself are some events with respect to S. So the null set is called the impossible events or the null event. Okay, so these are itself called the events of the S, right? Let us take one more example. Getting 7 when a die is thrown is called a null event, right? So the entire sample space is called a certain event, like getting 7 is null event. So entire sample space is called certain event. Correct. Next thing is simple event. So an event is called a simple event if it is singleton subset of the samples. Means we can write singleton subset of sample space S. Okay. Example like when a coin is tossed, sample space is head and tail, right? So now let A is H, the event of occurrence of head. Similarly, B is tail, the event of occurrence of tail. So A and B are sample events. Similarly, like dice thrown, a sample space is 1, 2, 3, 4, 5, 6. So let A be 5, the event of occurrence of 5, B 2, the events of occurrence of 2. So A and B are sample events. Okay. So this is very basics. Okay. With this, we are going to take a compound event. So it is the joint occurrence of two or more simple events. Okay. Means joint occurrence of two or more simple events. Okay. So example, the event of at least one head appears when two fair coin are tossed is a compound event. Means at least one head. That means possibilities are head tail, tail head, and head head. Correct. Next thing is equally likely events. So number of simple events are said to be equally likely if there is no reason for one event to occur in the preference to any other event. Meaning, in a drawing card, in a drawing card, 52 outcomes which are equally likely. Condition is these are well shuffled pack. Correct. So this is our equally likely event. Next term is exhaustive event. So all the possible outcomes taken together Okay, all the possible outcomes taken together. That means, like a card is drawn from well shuffled a pack. So the following events are executed like card is black, second is card is red, or we can take events are not executive, exhaustive, like card is hurt or the card is diamond. Okay, so like for the first two, A union B is S. So in general, we can write E1 union E2 union E3 up to En is S. Okay. And the last term, complement of an event. So the complement of an event A denoted by A bar, A dash, or AC is the set of all sample points of the space other than sample points in A. That means in an experiment of casting a fair die, S is equals to 1, 2, 3, 4, 5, and 6. Okay, so like if A is equals to 1, 3, 5, 6, then EC will be 2 to 4. Correct. AC is 2 and 4. So there is one note. A union EC is S, and A intersection AC is 5. Okay, so these two things you need to remember. Okay, so with this we are winding the lecture. Next class will start the mathematical definition of probability. Okay, so I hope you are clear the all the terms regarding it. So copied. Okay, so thank you guys. We'll see you in the next class.